Tonight, we are going to talk about something that is going to completely reshape how you think. About size, about distance, about everything you thought you knew, about what it means for something to be big. We are going to explore the largest object ever discovered in the universe. A structure so unfathomably massive that it makes entire galaxies look like floating specks of dust. I must warn you right now, by the time this terrifying journey concludes, you are going to look at the night sky differently. You are going to understand a concept of scale that most people never even try to comprehend. The stars you see outside your window will no longer look like comforting little lights, but rather distant, violently burning beacons in an ocean of absolute, terrifying darkness. Hello, and welcome to This is Space. I am Christopher, your guide through the infinite dark. If you enjoy these deep, atmospheric explorations into the unknown cosmos, please consider subscribing to the channel and leaving a comment below. Your support allows us to keep venturing further into the deep mysteries of the universe, peeling back the layers of reality one by one. Let us begin with something completely familiar to you. Think about your house, or the apartment where you live. The average house is perhaps 2,500 square feet. That is a space you can comfortably walk across in about 30 seconds. You know every single corner of it. You know the exact sound the floorboards make when you step on them, the way the light filters through the windows in the afternoon. This is a scale that makes perfect sense to your human brain, because you experience it every single day. Your ancient brain evolved on the plains of a small rocky planet to understand spaces exactly like this. These are spaces you can see with your own eyes, spaces you can physically walk through and measure with your own steps. A football field is 360 feet long. You could walk from one end to the other in maybe 2 minutes without breaking a sweat. A mile is 5,280 feet, which is roughly 17.5 football fields laid end to end. Most people can walk a mile in about 15 to 20 minutes. These are distances that feel substantial, but they are entirely achievable by a human being traveling on foot. The distance from New York to Los Angeles is about 2,800 miles. That is a 5-hour flight in a commercial airplane, or about 40 hours of driving if you somehow never stopped to rest or sleep. The circumference of planet Earth at the equator is about 24,901 miles. If you could somehow pave a perfectly smooth road around the entire planet and drive around it without ever stopping, traveling at highway speeds of 65 miles per hour, it would take you about 383 hours, which is almost 16 days of continuous, exhausting driving. To a human, the Earth feels massive. It feels like an entire universe of its own, filled with vast oceans, towering mountain ranges, and endless deserts. But here is the profound, unsettling reality. Compared to the scale of our local solar system, Earth is entirely tiny. It is a microscopic speck of blue and green dust caught in a beam of sunlight. And compared to the scale of the galaxy, the entire solar system is invisible. We are about to climb a terrifying ladder of cosmic scales where each rung makes the previous one look absolutely insignificant. The Moon, our closest celestial neighbour, is about 238,855 miles from Earth. When the Apollo astronauts travelled to the Moon in the late 1960s and early 1970s, they were going farther than any human had ever gone before in the entire history of our species. The journey took about 3 days at mind-bending speeds of roughly 24,000 miles per hour. The fastest you have probably ever travelled is in a commercial airplane, cruising at maybe 500 miles per hour. The Apollo spacecraft were moving nearly 50 times faster than that airplane, tearing through the vacuum of space. And it still took 3 whole days of endless blackness to reach the closest possible object to our planet. The distance to our local star, the burning centre of our system, puts all of this into terrifying perspective. Our star is about 93 million miles from Earth. If you could somehow build a magical bridge through space and drive a car there, at a highway speed of 65 miles per hour, non-stop, it would take you about 163 years. You would have to pass the driving duties to your children, who would pass it to their children, and somewhere around your great-great-great-grandchildren, the car might finally arrive at the violently burning surface of the star. Light travels at an absolute speed limit of about 186,282 miles per second. Every single second, light covers that immense, unimaginable distance. When you flip a switch in your room, the light from the bulb reaches your eyes essentially instantly because the distance is so short. But when you look at our star in the deep sky, you are not seeing it exactly as it is right now. You are seeing ancient light that left its boiling surface about 8 minutes and 20 seconds ago. If our star were to suddenly vanish or explode this exact second, we would not know about it for over 8 minutes. We would continue to walk around in the sunlight, completely oblivious to the fact that our doom had already occurred. Because of these enormous distances, astronomers use a standard measurement called the light year. Despite having the word year in it, a light year is not a measure of time. It is a measure of vast, terrifying distance. It is the absolute distance that a single photon of light travels in one entire year moving through the vacuum of space. If we do the math, light travels 186,282 miles every second. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and 365 days in a year. If we multiply all of these massive numbers together, we get approximately 5.88 trillion miles. That is just one single light year. The nearest star to our solar system, other than our own star, is called Proxima Centauri. It is a small, dim red dwarf star, about 4.24 light years away. That means the faint light you see from Proxima Centauri through a telescope tonight actually left that burning sphere over 4 years ago. It has been travelling silently through the absolute darkness of empty space, dodging cosmic dust and rogue planetary bodies for more than 4 years, covering nearly 25 trillion miles just to reach the lens of your telescope tonight. Within about 16 light years of our solar system, there are approximately 50 known stellar systems. This spherical region of local space, about 32 light years across from edge to edge, is our immediate local stellar neighbourhood. In cosmic terms, this entire neighbourhood is smaller than a single grain of sand resting on an endless beach. The Milky Way galaxy, our magnificent and terrifying home galaxy, is roughly 100,000 light years across. Just pause and try to imagine that number. A beam of light moving at 186,282 miles every single second would take 100,000 years just to cross from one side of our galactic home to the other. The galaxy is about 23,500 times wider than the distance to our nearest stellar neighbour. Our galaxy is a swirling disk of gas, dust and stars, containing somewhere between 100 billion and 400 billion stars. Each one of those stars is a massive nuclear furnace, a giant ball of compressed hydrogen undergoing violent nuclear fusion in its core. And practically every single one of those stars is now believed to have its own complex system of planets, moons, and asteroids orbiting around it in the dark. That means there are potentially trillions of planets just within our single galaxy, billions of which might be rocky worlds capable of holding liquid water. Our solar system is located about 26,000 light years from the very centre of the Milky Way. We reside in one of the quiet, dusty spiral arms, far away from the chaotic violence of the galactic core. When you look up at the night sky on a clear, dark night and see that faint, milky band of light stretching across the darkness, you are seeing the flat disk of our galaxy from the inside out. viewed edge-on. You are looking through the thickest part of the disk. You are seeing hundreds of billions of stars so impossibly distant that their individual points of light blur together into one continuous, ghostly glow that looks like spilled milk across the heavens. The star at the centre of our solar system orbits the massive centre of the Milky Way at a mind-bending speed of about 515,000 miles per hour. We are currently hurtling through the vacuum of interstellar space at this unimaginable velocity. But the galaxy is so vast, so unfathomably huge, that even at this extreme speed, it takes our solar system about 225 to 250 million years to complete a single grand orbit around the galactic centre. The last time our solar system was in its exact current position in the galaxy, dinosaurs had not even evolved yet. The Earth was in the middle of the Triassic period, dominated by strange ancient reptiles that have been dead for eons. Since that ancient time, the dinosaurs evolved into massive giants, dominated the entire planet for over 160 million years, and were wiped out by a catastrophic asteroid impact that darkened the sky and poisoned the oceans. Mewled. Mammals timidly took over the empty landscapes. Primates eventually evolved in the dense canopies. Humans finally appeared, learned to control fire, built grand civilizations of stone and steel, invented modern technology, launched probes into the dark, and finally looked up at the stars with understanding. All of human history, every war, every triumph, every life ever lived, has happened in a tiny fraction of a cosmic second, and we have only just now completed one single lap around the galactic core. Now you must realize that the Milky Way is not alone in the dark. It is not an isolated island. The Milky Way is part of a small, gravitationally bound collection of galaxies called the Local Group. The Local Group contains more than 80 known galaxies, mostly small, irregularly shaped dwarf galaxies that orbit the larger ones like buzzing insects. The three largest members of this group are the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. The Andromeda Galaxy is our massive galactic neighbour. It is about 2.537 million light-years away. When you look at Andromeda in the night sky, and you can actually see it with your naked eye as a fuzzy smudge of light if you know exactly where to look on a dark night, you are seeing ancient light that left that giant spiral over 2.5 million years ago. When that light began its journey toward your eye, our earliest human ancestors were just beginning to walk upright on the plains of Africa. They had not even evolved yet. Everything you know about human civilization has happened while that light was silently travelling through the deep vacuum of intergalactic space toward you. And here is a terrifying fact about Andromeda. It is not just sitting there toward the Milky Way at about 250,000 miles per hour. In about 4 massive island universes will violently collide in the dark. The delicate spiral arms will be completely torn apart by gravity. Gas clouds will smash together, igniting massive waves of star formation. The supermassive black holes at the centre of each galaxy will spiral toward each other and eventually merge, sending ripples of gravity tearing through the fabric of space itself. Eventually, billions of years after the collision begins, the two galaxies will settle into one massive, featureless, elliptical galaxy. The night sky of Earth, if the planet still exists, will be permanently changed, ablaze with the chaotic light of 1 trillion rearranged stars. The Local Group is about 10 million light-years across. That is 100 times the diameter of the entire Milky Way. And yet, in the grand scheme of things, the Local Group is a tiny, insignificant structure. The Local Group is part of a much larger, more terrifying structure called the Virgo supercluster. A supercluster is a massive group of galaxy clusters and galaxy groups all permanently bound together by the relentless force of gravity. The Virgo supercluster contains at least 100 galaxy groups and clusters, including our own Local Group. It is about 110 million light-years across. In the year 2014, astronomers fundamentally redefined our cosmic address by discovering that the Virgo supercluster is just one small lobe, just an insignificant branch of an even larger, more terrifyingly massive supercluster called Laniakea. The beautiful name comes from ancient Hawaiian words meaning immense heaven. Laniakea contains about 100,000 massive galaxies and stretches an unbelievable 520 million light-years across the dark. To put that into perspective, if the Milky Way galaxy were shrunk down to the size of a small coin, Laniakea would be about the size of the entire United States of America. Laniakea is defined not just by the sheer number of burning galaxies it contains, but by how those galaxies actually move through the deep void. All the galaxies in Laniakea, including our own Milky Way and Andromeda, are flowing like a slow cosmic river toward a mysterious invisible region called the Great Attractor. This is a terrifying gravitational anomaly located at about 250 million light-years away in the direction of the Centaurus constellation. We cannot see exactly what the Great Attractor is, because it lies in a region of the sky known as the Zone of Avoidance, obscured by the thick dust and gas of our own Milky Way galaxy. But whatever is hiding back there possesses the mass of tens of thousands of galaxies, and it is relentlessly pulling us, and everything around us, toward its unseen center. Now, you might naturally think that Laniakea, with its 520 million light-year diameter and its 100,000 galaxies, would certainly be among the largest structures in the entire universe. But it is not even close. As we drift deeper into the structure of the universe, take a moment to subscribe to This is Space and leave a comment sharing your thoughts. Are we merely microscopic inhabitants of a cosmic giant? What do you think lies hidden within the Great Attractor? Let us know below. This terrifying realization brings us to the fundamental architecture of the cosmos itself. The universe is not evenly distributed. Galaxies are not scattered randomly through empty space like confetti thrown into the air or sand scattered on a floor. Instead, they are organized into an incredibly complex, interconnected structure that scientists aptly call the cosmic web. I want you to close your eyes and think of a three-dimensional spiderweb stretching across the entire observable universe, woven in the absolute dark. The shimmering strands of this web are called filaments, and they are made entirely of billions of galaxies, massive galaxy clusters, boiling hot intergalactic gas, and dense strings of invisible dark matter. Where these cosmic filaments intersect, where the threads of the web cross each other, you find incredibly massive galaxy clusters containing thousands upon thousands of violently active galaxies. And between the glowing filaments, between the threads of the cosmic web, are enormous, terrifyingly empty regions called cosmic voids, where almost absolutely nothing exists. These voids are spheres of darkness hundreds of millions of light-years across. This cosmic web structure emerged from tiny microscopic variations in the density of matter in the very early universe, shortly after the Big Bang. Matter was not perfectly evenly distributed when the universe cooled. Some microscopic regions were ever so slightly denser than others, maybe by just 1 part in 100,000. It was a nearly perfect, smooth soup of plasma. But over billions of years, the cold, patient hand of gravity amplified these tiny differences. Denser regions steadily pulled in more matter from their surroundings, became denser still, and pulled in even more matter in a runaway process. Less dense regions became emptier, as their matter was slowly dragged toward the denser areas. The cosmic web we see today is the magnificent, violent product of 13.8 billion years of slow gravitational evolution. Dark matter, a mysterious, invisible substance which makes up about 27% of the mass energy of the universe, created the invisible scaffolding on which all visible matter currently hangs. Dark matter does not interact with light, but its gravity dictates the shape of the cosmos. Dark energy, a completely different, And even more mysterious phenomenon, making up about 68% of the universe, is aggressively driving the acceleration of cosmic expansion, trying to tear the web apart. Ordinary matter, the stuff made of protons, neutrons, and electrons, the material that makes up every star, every planet, every mountain, and every human being that has ever lived, accounts for only about 5% of the universe. The complex invisible interplay between these unseen components shaped the cosmic web into what we boldly observe with our telescopes today. Galaxy filaments are among the largest known structures in the entire universe. A single filament can be hundreds of millions of light years long, containing thousands of galaxies strung out like glowing beads on a cosmic necklace. But even these massive, glowing filaments are not the largest structures we have found hidden in the deep dark. The Great Walls came next in our slowly evolving understanding of cosmic architecture. The first Great Wall was discovered in the year 1989 by American astronomers Margaret Geller and John Huchra. They were painstakingly mapping the three-dimensional positions of galaxies in a thin slice of the deep sky. What they found completely shocked them and forever changed cosmology. Instead of a random distribution of galaxies, they saw a massive, solid, continuous sheet of galaxies stretching across their entire survey. This massive structure, which they called the CFA2 Great Wall, was about 500 million light-years long, 300 million light-years wide, and about 15 million light-years thick. It looked like a literal wall of light spanning the darkness. But the CFA2 Great Wall was just the very beginning. As astronomers mapped more and more of the distant universe, building three-dimensional maps of millions of galaxies, they kept finding bigger and bigger structures. In the year 2003, astronomers discovered the Sloan Great Wall. The Sloan Great Wall is approximately 1.37 billion light-years long. Light itself, moving at its absolute maximum speed, would take 1.37 billion years just to travel from one end of this wall to the other. The Saraswati supercluster, discovered in 2017, is about 652 million light-years across and contains about 400 massive galaxies arranged in a giant wall structure. It is located about 4 billion light-years away from us, meaning we see it exactly as it looked 4 billion years ago. The South Pole Wall, discovered in 2020, is a massive filament of galaxies stretching at least 1.4 billion light-years across. It sits silently behind the plane of the Milky Way, in a region of the sky called the Zone of Avoidance, where thick gas and dust from our own galaxy completely block our view in visible light, requiring astronomers to use radio and infrared telescopes to peer through the galactic fog. For years, astronomers furiously debated which massive structure held the absolute record for the largest object in existence. The Hercules Corona Borealis Great Wall, discovered in 2013 through the detection of gamma-ray bursts, was long considered a serious contender. It appeared to span up to an incredible 10 billion light-years across. However, its true status has remained deeply controversial, with many scientists arguing it might just be a statistical illusion or a series of smaller structures lining up perfectly from our point of view. But in early 2025, astronomers made a shocking discovery that finally settled the fierce debate about what holds the true record for the largest confirmed, physically coherent structure in the observable universe. They found Quipu. Quipu has an estimated, staggering mass of about 200 quadrillion times the mass of our star. Written out, that is 200 quadrillion solar masses. Just to understand that number, if you tried to count to 200 quadrillion, counting one number per single second without ever stopping to sleep, eat, or breathe, it would take you about 6.3 billion years. Planet Earth would be completely uninhabitable, swallowed by the expanding red giant phase of our dying sun, long before you even came close to finishing counting. The name Quipu comes from the ancient Incan recording system that used deeply complex knotted chords to store vital information, mathematics, and history. The brilliant astronomers who discovered it chose this ancient name because the structure deeply resembles a complex network of interconnected threads, with massive glowing galaxy clusters forming the dense knots along the cosmic cords. It is a highly fitting name for something so physically intricate and terrifyingly vast. What makes Quipu particularly significant in the realm of astrophysics is that it is a confirmed, gravitationally coherent structure. Quipu was definitively detected through high-energy X-ray emissions, originating from the incredibly hot, boiling gas that pervades galaxy clusters. This gas, heated to tens of millions of degrees by the violent gravitational collapse that originally formed the massive clusters, emits powerful X-rays that we can clearly detect from Earth using specialized space telescopes like Chandra and XMM Newton. The glowing pattern of these X-ray emissions perfectly reveals the physical bridges and connections between the far-flung clusters, confirming beyond a shadow of a doubt that they are part of a single enormous, interconnected structure rather than just an accidental alignment of unrelated objects in the deep sky. The 68 distinct galaxy clusters that make up the knots of Quipu are arranged perfectly along massive filaments of dark matter that stretch across the dark void between them, permanently connected by glowing bridges of hot gas and gravitationally bound into one single, terrifyingly large system. Each of these 68 individual clusters is itself a massive structure containing hundreds or thousands of large galaxies, dwarf galaxies, and trillions upon trillions of individual burning stars. Together, they form a single entity that is almost too large for the human mind to ever truly comprehend. The discovery of Quipu seriously challenges our entire foundational understanding of how the universe evolved. According to standard cosmological models, which scientists have trusted for decades, structures this incredibly large should not be able to physically form in the time the universe has existed. The universe is supposed to be homogeneous and isotropic at large scales. What that scientific term means is that when you zoom out far enough, the universe should look exactly the same in every single direction. It should look like a smooth, even fog of matter. Everything should average out to a uniform, boring smoothness. This fundamental principle, called the cosmological principle, has been a central cornerstone of our understanding of the universe for nearly a century. Quipu appears to push violently against this theoretical limit, breaking the rules of cosmic structure. It is so impossibly large that explaining how it formed within the relatively short 13.8 billion year history of the universe requires very careful, entirely new physical analysis. Did gravity work differently in the early universe? Did dark matter collapse faster than we predicted? The honest answer is that we do not fully know yet. Quipu is a dark mystery, a massive glowing challenge to our scientific understanding, and a stark reminder that the universe is far larger and infinitely stranger than we ever imagined in our wildest theories. The galaxy clusters that make up the knots of Quipu deserve much closer, careful attention, because understanding these massive components helps us truly appreciate the terrifying whole structure. Galaxy clusters are the largest gravitationally bound structures in the universe. They are the true behemoths of the cosmos. Unlike the loose filaments and great walls, which are basically just loose associations of galaxies drifting slowly along the cosmic web like foam on a wave, galaxy clusters are dense, violent concentrations of galaxies permanently locked together by intense gravity. The galaxies within a cluster frantically orbit a common center of mass, permanently trapped by the massive, inescapable gravitational pull of the entire cluster. A typical galaxy cluster contains hundreds to thousands of swirling galaxies, plus vast, unseen amounts of boiling hot intergalactic gas and enormous halos of dark matter. The seemingly empty space between galaxies in a cluster is not actually empty at all. It is filled with a plasma gas that can reach temperatures of 100 million degrees or more. It is so hot, so energetic, that it aggressively emits powerful X-rays that light up the dark. This incredibly hot gas actually contains more physical mass than all the glowing, visible galaxies in the entire cluster combined. The galaxies are just the tip of the cosmic iceberg, and the dark matter contains even more mass than the hot gas, typically about 5 to 6 times as much. The massive clusters inside Quipu are intimately connected by thick, invisible filaments of dark matter and hot gas, forming an unbreakable network that spans 1.4 billion light-years from end to end. The gravitational influence of each individual cluster extends far beyond its visible, glowing boundaries, reaching out through the dark millions of light-years to interact with neighbouring cluster galaxies and aggressively maintain the structural integrity of the whole Quipu system. When these massive galaxy clusters collide with each other, which inevitably happens when the strands of the cosmic web pull them together over eons, the explosive results are among the most energetic and violent events in the entire universe since the Big Bang itself. It is a clash of cosmic titans. The galaxies themselves rarely hit each other directly during these collisions, because the vast spaces between individual galaxies are so enormous that they basically pass through each other like ghosts. But the boiling hot gas that completely fills each cluster does collide head-on. This creates massive intergalactic shock waves that heat the gas to even higher, unimaginable temperatures, stripping galaxies of their star-forming material. On a scale of millions of light-years, these cosmic mergers are not quick events. They can take billions of years to fully complete, during which time the clusters slowly, violently merge into a single, even more massive structure, their supermassive black holes eventually finding each other and merging in a burst of gravitational waves. Within the vast expanse of Quipu right now, some clusters may currently be in the slow, agonizing process of merging. Others may have finished merging billions of years ago, settling into a quiet, massive sphere of dark matter and dead red galaxies. Still others may be slowly approaching each other in the dark, caught in a gravitational dance, destined to violently collide in the distant, unseen future. The structure is dynamic, evolving, and constantly changing its shape and composition over deep cosmic timescales. As we explore the violent reality of galaxy clusters, remember to subscribe to This is Space. What would it look like to witness two galaxy clusters colliding from a safe distance? Let your imagination run wild in the comments section. Now, we must turn our attention away from the light and look at the absolute darkness. We must look at the voids between structures like Quipu, which are fascinating, isolating, and deeply terrifying in their own right. Cosmic voids are the least dense regions of the entire universe. They are the empty rooms in the cosmic mansion. They are not completely empty, because a true, perfect vacuum does not exist. Even the emptiest voids contain some tiny amount of matter, perhaps a thin scattering of lonely, isolated dwarf galaxies, extremely thin clouds of invisible primordial gas, and faint dark matter halos. But compared to the glowing filaments and bustling clusters, voids are practically perfect vacuums of death. The average density in a void might be 1/10 or even 1/20th of the average density of the rest of the universe. The largest known void in our mapped universe, the giant void or Booty's void, is about 330 million light-years across. It is an ocean of nothingness. Within this enormous, silent, spherical region, only about 60 galaxies have ever been found by our telescopes. That sounds like a lot of galaxies, until you realize that a similarly sized volume elsewhere in the dense parts of the universe might easily contain 2,000 massive galaxies or more. The Boot's void is so empty that if the Milky Way galaxy had been placed precisely in the centre of it, we would not have even known other galaxies existed until the invention of powerful deep space telescopes in the 1960s. What would it actually be like to exist inside a void? Imagine an intelligent civilization evolving on a lonely rocky planet, orbiting a star inside the Boot's void. When they looked up at their night sky, they would see almost absolutely nothing but the stars of their own galaxy. Their own galaxy would be visible, a faint, beautiful band of stars stretching across the absolute darkness, but the distant, comforting glow of other neighbouring galaxies would be almost impossible to detect without advanced technology. Their cosmic horizon would feel much closer, much more confining, isolating and claustrophobic. They might naturally, logically conclude that their lonely galaxy was entirely alone in the whole universe, an isolated, accidental island of matter floating forever in an infinite, dead and uncaring emptiness. The psychological impact of realizing you are utterly alone in a void of 300 million light-years would be staggering. The dark voids and the glowing filaments are two sides of the exact same cosmic coin. You cannot physically have one without the other. The matter had to be pulled from the voids to build the massive walls and clusters. Picture in your mind what it would be like to actually travel across the entire length of Quipu. You board an impossible spacecraft, a vessel of human imagination that can accelerate instantly to the exact speed of light. You position yourself at one edge of Quipu and begin your epic crossing. The structure stretches endlessly before you, 1.4 billion light-years of dense galaxy clusters, glowing gas filaments, boiling hot plasma, and invisible dark matter structures. For the first million years of your journey at light speed, you travel through relatively sparse, quiet regions. Quipu is not uniformly dense. It has massive structure within structure, empty pockets within the dense threads. Occasionally you pass a lone, wandering galaxy, a beautiful spinning spiral of light containing billions of stars, isolated from the main clusters. But mostly, as you look out the window of your ship, there is only emptiness, thin wisps of intergalactic gas, the invisible pull of dark matter, and the faint, cold microwave glow of the cosmic microwave background. After 10 million years of travelling at the absolute speed of light, you finally encounter your first major galaxy cluster. You see hundreds of massive elliptical and spiral galaxies spread across millions of light-years, deeply embedded in a dense cloud of gas so hot it glows violently in X-rays, illuminating the dark. You fly directly through this cluster over the next few million years, watching galaxies slowly drift past your window, each one a collection of hundreds of billions of burning stars, planetary systems, and perhaps entirely different forms of life. Then you exit the cluster and enter more relatively empty space. Filaments of matter, like glowing highways, stretch endlessly between the next clusters. You follow these glowing filaments, watching the majestic, terrifying cosmic web unfold all around you in the dark. After 100 million years of travel, you have crossed less than a tenth of Quipu. Back on Earth, if the Earth even still physically exists, 100 million years have passed. The continents have violently shifted, broken apart, and collided again. Massive mountain ranges have risen from the crust and entirely eroded away into dust. Entire groups of species have evolved, dominated the ecosystem, and gone completely extinct, leaving only fossils behind in the deep rock. And you, moving at the speed of light, are still near the very beginning of your cosmic journey. You continue onward, pushing deeper into the structure, cluster after massive cluster, filament after glowing filament. The structure seems absolutely endless, a fractal of cosmic architecture. Each cluster you silently pass contains its own unique collection of galaxies, its own unique, violent patterns of boiling hot gas, and its own deep history of formation, starbursts, and dark galactic mergers. After 500 million years of continuous flight, you are about a third of the way across the Great Quipu. On Earth, If the planet was sterilized by a disaster, complex life might be evolving for the first time all over again in the oceans. Or perhaps life has gone completely extinct forever, leaving a barren rock orbiting a sun. 500 million years is enough deep time for almost anything to happen in the dark. Entire civilizations could rise to the stars and fall back to dust in that time. After 1 billion years of travel, you are finally approaching the far side of Quipu. Our home star, the Sun, has changed noticeably. It is burning significantly brighter and hotter than it was when you first left, burning rapidly through its remaining hydrogen fuel in its core. The oceans of Earth may be beginning to slowly boil and evaporate into space. The gentle, perfect conditions that allowed human life to flourish are permanently fading into ancient memory. Finally, after 1.4 billion years of continuous travel at the absolute speed of light, you emerge from the far side of Quipu. Behind you lies the largest known structure in the universe, an architectural marvel of gravity containing billions of galaxies, trillions upon trillions of stars, and countless unseen, silent worlds. Ahead of you lies whatever lies beyond, more cosmic web, more glowing, branching filaments, more terrifyingly empty voids, more massive, unnamed structures waiting in the dark to be discovered by whoever comes next. Zooming out one final time, pulling our perspective back to the absolute limit, we must deeply consider the observable universe as a whole. The observable universe is a massive, spherical bubble of reality centered directly on Earth, with a radius of about 46.5 billion light-years in every single direction. You might naturally wonder how that physical size is even possible if the universe is only 13.8 billion years old. How can the radius be larger than the age of the universe times the speed of light? The terrifying, counterintuitive answer is that space itself has been aggressively, constantly expanding while the light was travelling toward us. When we look through a telescope at a distant galaxy, whose ancient light took 13 billion years to reach our mirrors, that galaxy has not just been sitting there. It has been moving away from us due to the relentless physical expansion of cosmic space the entire time the light was in transit. By now, in the present cosmic moment, that galaxy is much, much farther away than 13 billion light-years. It is currently located tens of billions of light-years away. Within this massive observable sphere, there are approximately 2 trillion glowing galaxies. Each single galaxy contains billions or hundreds of billions of individual stars. The total estimated number of stars in the observable universe is roughly around 200 billion trillion. That is a 2 followed by 23 zeros. It is a number that defies human comprehension. It is estimated that there are more stars in the observable universe than there are grains of sand on every single beach and in every single desert on planet Earth. And we now know, thanks to missions like the Kepler Space Telescope, that most stars have complex systems of planets orbiting them. The number of planets in the observable universe is probably similar to, or even much larger than the number of stars. That means there are quintillions of rocky worlds, gas giants, ice planets, and completely bizarre worlds we cannot even imagine, all floating in the dark. And here is the truly humbling, terrifying thing about all of this. The observable universe is not the entire universe. The observable universe is strictly just the small part we can actually see, the small bubble of reality limited by the finite speed of light and the finite age of the cosmos. It is an optical illusion of our specific location in time and space. There is almost certainly far more universe beyond our cosmic horizon, massive, infinite regions of space, so far away that the light from their galaxies has not had enough time to reach us yet since the Big Bang occurred. And due to the accelerating expansion of space driven by dark energy, light from those distant realms never, ever will reach us. The light is fighting an uphill battle on a treadmill that is moving faster than it can run. How much more universe is out there in the dark beyond the horizon? We truly, fundamentally, do not know. Some mathematical theories suggest the universe might be completely, physically infinite, stretching endlessly and violently in all possible directions without any boundary or edge. If the universe is infinite, then every possible combination of matter must exist somewhere. Other theories suggest it might be finite but unbounded, like the curved surface of a sphere or a higher dimensional shape, meaning if you travelled far enough in one direction, you would eventually return to where you started. The honest, terrifying answer is that we have no way of ever verifying what lies beyond the edge. This profound fact means Quipu, as unbelievably large as it is, might be considered entirely microscopic, a negligible speck of dust, compared to the true massive structures hidden deep beyond our cosmic horizon. The universe is continuously expanding, and that expansion is accelerating. Dark energy, a phantom force we cannot see or measure directly, is aggressively pushing the fabric of the universe apart at an ever-increasing rate. Distant galaxies are rapidly receding from us as empty space literally expands, inflates, and stretches between us and them. The farther away a galaxy is from us, the faster it appears to be receding into the dark. For galaxies that are currently far enough away, near the edge of our observable bubble, the space between us and them is actually expanding faster than light can travel through it. This does not violate Einstein's cosmic speed limit, because the distant galaxies themselves are not moving faster than light through local space. They are essentially stationary in their local area of space, floating peacefully. But the empty space itself between the galaxies is expanding so rapidly that the vast distance between us grows much faster than light could ever hope to traverse it. This has dark, profound, and melancholy implications for the deep future of massive structures like Quipu. As the universe continues to relentlessly expand forever, the slow gravitational growth of cosmic structure will inevitably slow down and completely stop. Dark energy will eventually win its long, slow battle against the pulling force of gravity. Massive galaxy clusters that have not fully merged yet will never merge. They will be pulled apart before they can touch. Glowing filaments will snap and stop growing. The entire cosmic web, the beautiful structure we observe today, will eventually freeze into its final, dying configuration. In the far, deep future, perhaps tens of billions of years from now, Quipu will be totally isolated from everything else. The glowing connections and gas bridges between its clusters may thin out or completely break apart due to the stretching of space. The structure will persist for a time, but it will be surrounded by an ever-expanding, terrifyingly cold void as the rest of the universe silently recedes far beyond our technological ability to observe. Future civilizations, looking up at the sky billions of years from now, will see a dark, empty universe, completely unaware that a massive cosmic web ever existed. We are nearing the end of our dark journey tonight. If this voyage across billions of light years has expanded your perspective on life and reality, please subscribe too. This is Space, and leave a comment to help our community grow and reach more curious minds. We must consider the ancient stars we can see with our naked eyes, and what their ancient light tells us about distance and deep time. When you look up at the night sky, you are not seeing stars exactly as they are right now in the present moment. You are seeing a ghost. You are seeing light that has travelled for years, centuries, or even millennia to reach your sensitive eyes. Distance and time become completely, physically inseparable in astrophysics. You cannot separate where something physically is from when you are seeing it. Sirius, the brightest star in our night sky, is 8.6 light years away. When you look at the brilliant light of Sirius tonight, you are seeing light that left that star 8.6 years ago. If you are a young adult, you are seeing Sirius exactly as it looked when you were a child. Vega is another brilliant, bright star, about 25 light-years away. If you look at Vega tonight, you might be seeing light that left that burning star the very year you were born. Your entire life has happened while that light was crossing the dark. Betelgeuse, the massive, angry red supergiant in the constellation Orion, is about 550 light-years away. The reddish light you see from Betelgeuse tonight started its long, silent journey toward Earth in the year 1474, during the height of the Italian Renaissance. The modern world as we know it, with computers, electricity, and spaceflight, did not exist yet. Betelgeuse is particularly fascinating because it is a massive, unstable star nearing the violent end of its short life. At some point, the core of Betelgeuse will collapse, and the star will explode as a massive, catastrophic supernova. When it does explode, it will briefly shine as bright as the full moon in our sky, casting shadows at night, and visible even during the bright day. But here is the terrifying, mind-bending thing. Betelgeuse might have already exploded. The violent explosion might have happened centuries ago in the dark, tearing the star apart and sending a shockwave through its local space. But we would not know yet. The blinding light from that catastrophic explosion would still be travelling toward us through the vacuum of space right now, taking 550 years to make the long journey to our eyes. Every single star you see in the night sky is a literal, physical window into the deep past. You are not seeing the universe as it currently is. You are seeing the universe exactly as it was. This has profound, terrifying implications for how we fundamentally understand massive structures like Quipu. When we boldly observe the entirety of Quipu through our telescopes, we are actually seeing different physical parts of it at completely different times in history. The near edge of Quipu, located 425 million light-years away from Earth, appears exactly as it was 425 million years ago. The far edge of the structure, located 800 million light-years away, appears as it was 800 million years ago. We are not seeing Quipu as a single coherent snapshot frozen in a single moment of time. We are seeing it violently smeared across 375 million years of deep cosmic history. We are seeing a physical timeline stretched across the dark. This brings us to the haunting, inevitable question of what these massive cosmic structures mean for the possibility of biological life elsewhere in the infinite dark. Given the vast, incomprehensible number of stars and planets, given that the universe is 13.8 billion years old and has had plenty of time to cook up the ingredients for biology, it seems incredibly, statistically likely that life should exist elsewhere. The universe is composed of the same chemical elements everywhere, and yet we have never detected any clear, undeniable signs of alien civilizations. We have heard no organized radio signals. We have seen no massive, unnatural laser pulses. We have observed no alien megastructures blocking the light of distant stars. Absolutely nothing. Utterly silent. This is the core of the Fermi paradox. The vast, unfathomable distances measured in light years might be the dark, depressing answer to this silence. The distances between individual stars are so enormous that they present almost insurmountable physical barriers to communication and travel. Our own human radio signals, television broadcasts, and radar pings have been leaking out into space for about a century now. They have reached all stars within a sphere of about 100 light-years of Earth. That sounds like a large area, but the Milky Way galaxy alone is 100,000 light-years across. Even if there is a highly advanced technological civilization living on a lonely, beautiful planet deep within the clusters of Quipu, even if they have been aggressively broadcasting powerful radio signals into the dark, for millions of years hoping someone will listen, those signals would take hundreds of millions of years to reach our antennas. And if we heard them and sent a response, our response would take hundreds of millions of years to reach them. By the time the message arrived, the civilization that sent the original signal might have been dead and buried for eons. Meaningful, two-way communication across these cosmic distances might simply be governed by the laws of physics to be impossible. Each intelligent civilization develops entirely alone on its own rock, asks its profound questions alone, builds its monuments alone, and eventually dies alone in the cold dark, never knowing for sure if anyone else was ever out there sharing the universe with them. There is something profoundly melancholy, deeply sad about this physical reality. But it also means every single civilization that does manage to arise from the dust is incredibly, unbelievably precious. If we are truly isolated by distance, then what we do here on this tiny blue marble matters immensely. We are deeply, physically connected to this massive cosmic web. The heavy atoms in your body, the carbon in your cells, the oxygen you breathe, the nitrogen in your DNA, and the iron pumping through your red blood were not present at the beginning of the universe. The Big Bang only created hydrogen and helium. All the heavier elements were violently forged inside the burning cores of ancient massive stars and spread violently through space when those massive stars died in catastrophic supernova explosions billions of years ago. The matter coalesced into clouds, which formed our solar system, which eventually formed you. You are literally, scientifically made of ancient stardust. Quipu is 1.4 billion light-years across. It contains 68 massive galaxy clusters, trillions upon trillions of burning stars, and countless unseen, silent worlds drifting in the dark. It took billions of years of patient gravity to form in the dark, and will persist for billions more before fading away. And you, a relatively small, highly complex, temporary arrangement of conscious atoms walking around on the surface of a tiny rock, can actually comprehend it. The universe is a vast, empty, terrifying place with tiny, warm islands of light, separated by enormous oceans of absolute darkness. And yet those isolated islands are deeply, physically connected by ancient light, connected by the invisible threads of gravity, and connected by a shared deep history tracing back to the beginning of time. The universe is physically looking at itself through your conscious eyes. Every time you gaze at the sky, the cosmos is trying to understand itself. Thank you for taking this long, terrifying, and beautiful journey into the dark with me tonight. Sleep well. Keep looking up at the sky, and never stop wondering about the vast, terrifying, and endlessly beautiful universe we call our permanent home.